Hello students, good morning. So today we are going to start the next topic, that is thermodynamics. Okay, so first we will discuss about the synopsis. Not clear, one second.
What?
Okay, so today we are going to discuss thermodynamics. So first we are going to discuss about the question answer, that is synopsis regarding the thermodynamics here. So here is the slide, that is what do you mean by thermodynamics? So thermodynamics, it will be visible just a minute. That is thermodynamics, it is a branch of physics which deals with thermodynamics is a branch of physics which deals with, that is the process of involving heat and work and internal energy. Okay, so thermodynamics antandre enu? So in physics we have many branches. In that some are dealing with the that is electricity, that is a current related concept. Then we have magnetism where we can study about the magnets. Then we have the light related topics, optics. So thermodynamics antandrenu, it is a branch which will deal with the, that is heat, work and the internal energy. So here the thermodynamics is concerned with macroscopic behavior rather than microscopic behavior of the system anta ಹೇಳ್ತಾರೆ. So what do you mean by this one? Here there are some what we can say, that is quantities which are referred as macroscopic and some are referred as microscopic. So in that the thermodynamics deals with the macroscopic behavior. It deals with macroscopic behavior. Okay. So here let us see what are the macroscopic properties. So in that first one we have the internal energy. So internal energy antandrenu, this is nothing but the sum of kinetic and the potential energy. So please students mute yourself. That is internal energy is nothing but what? It is the sum of kinetic energy and the potential energy of the atoms per molecule or molecules consisting of in a system. This is called as internal energy. We know that the molecules or the atoms, so all are possessing two types of energies, that is kinetic energies and the potential energies. When kinetic energy, we can say when objects or the molecules or the atoms are moving, that is called as what? Kinetic energy. Then when they are at rest, here, that is called as what? That is potential energy. Right? Then next, here when we can take the potential energies, when we can take these potential energies. Other students mute yourself.
Voice break ಆಗ್ತದೆ ma'am.
Ramya, mute yourself. If there is no disturbance from others, then you will get my voice clearly. So please mute yourself. Whatever
Yeah, ma'am, voice to
in
break
the chat box, you just okay. Now you just check. That is here the internal energy is taken as internal energy. Now delta U anta denote ಮಾಡ್ತೀವಿ. So the internal energy is taken as positive if the internal energy of the system is increasing. So internal energy of the system, if it is increasing, then it is called as what? Positive. Internal energy decrease ಆಗ್ತಾ ಇದ್ರೆ, so for a given system, if the internal energy is decreasing, then it's taken as negative. Then heat is the, what do you mean by heat? It is the part of internal energy which is transferred from one body to the other body. So heat antandre enu, that is it is the part of internal energy. It transfers from one body to other body. So what do you mean by one body to other body? One body to other body antandre higher body to lower body. Now also it is not clear. Yes. Then next we have the work done here. How we can define the work done? Okay. So work is said to be done when a force acting on a system displaces body in its own direction. So generally work hege defined ಮಾಡ್ತೀವಿ, that is work done is defined as force into displacement. Okay. So in case of thermodynamics, so work is equal to force into displacement anta ಹೇಳ್ತಾರೆ. In case of thermodynamics, this work done is written as P delta V. So P ಅಂತಂದ್ರೆ pressure ಆಗುತ್ತೆ, delta V ಅಂದ್ರೆ change in the volume ಅಂತ consider ಮಾಡ್ತೀವಿ. So here you can see the note point, that is if the gas expands, work is said to be done by the system. So in this case, the final volume is greater than the initial volume. Therefore, work done will be positive. Next, if the gas is compressed, gas expand ಆದಾಗ ಏನಾಗುತ್ತೆ, final volume ಜಾಸ್ತಿ ಆಗುತ್ತೆ initial volume ಗಿಂತ, ಅವಾಗ work done ನಾವು positive ಅಂತ ಹೇಳ್ಬೋದು. If the gas is compressed, so reverse case ಅಂತಂದ್ರೆ, that is compared to the final volume, the initial volume will be greater one. Therefore, work done is said to be negative. Then the next slide, that is, so what do you mean by the thermodynamic variables or parameters? The thermodynamic variables or the parameters are nothing but the quantities like temperature, volume, pressure, internal energy. These are known as what? Thermodynamic variables. Okay, these are called as thermodynamic variables, or it is also said to be parameters of the system. Then next we have the equation of state. What do you mean by equation of state? The relation between the values of any of the three thermodynamics for the system is called its equation of states. So what do you mean by equation? It is nothing but the relation. So the pressure, volume, temperature, or internal energy. The relation what you are getting, that is called as the equation of state. Then next we have equilibrium of a system. A system is said to be in equilibrium if its macroscopic quantities do not change with the time. So what do you mean by equilibrium state? Equilibrium state antandre, so two systems when they are in thermal equilibrium with each other, then this is called as what? Equilibrium of a state. So in case of equilibrium of a state, here the macroscopic quantities we will consider. Next, the relation between joule and the calorie. So you remember this conversion factor. So what is the conversion factor here? That is 1 joule is equal to 4.186 calories. 1 joule is equal to 4.186 calories. This is the relation between joule and the calorie. Joule antandre SI unit agate, calories antandre it is CGS unit. Yes. Then the laws we will start here. That is zeroth law of thermodynamics. What is zeroth law of thermodynamics? So you can see the figure here. Ee figure enna nodidre enanta gottagatte illi nodi. That is A is in relation with C, then A is in relation with B also, and you can see the relation between A and C also. So what is this zeroth law of the thermodynamics? So the figure is explained here. When a body A is in thermal equilibrium with another body B, then and also separately in the thermal equilibrium with a body C. So nimdu A body ide, this A body thermal equilibrium with C also, this is in thermal equilibrium with B also. Then the body B and C will also be in thermal equilibrium with each other. So now ಇಲ್ಲಿ mathematics ಅಲ್ಲಿ ಹೇಳ್ತೀವಿ, that is if A is equal to B, B is equal to C, then A is equal to C anta. So you can remember zeroth law of thermodynamics in short with that one. So your A is in thermal equilibrium with C also, A is in thermal equilibrium with B also. Therefore, B and C will be in equilibrium with each other. This is the statement of zeroth law of thermodynamics. Okay, the standard statement you can see it down. The zeroth law of thermodynamics states that if two thermodynamic systems are each in thermal equilibrium with the third system or the third one, then they are in thermal equilibrium with each other. Okay, next, the first law of thermodynamics. So equation you can see, that is delta Q is equal to delta U plus delta dW. right? So U is internal energy, change in internal energy. Then dW is the change in the work. dQ is the, this is heat required. Aita? So what is the statement here? You can see equation anna nodidre namge ಏನು ಗೊತ್ತಾಗುತ್ತೆ? Heat is equal to ನಾವು ಏನಂತ ಬರ್ದಿದ್ದೀವಿ? Sum of internal energy and work done ಅಂತ ಬರ್ದಿದ್ದೀವಿ. So same way we are going to define it. If the quantity of heat supplied to a system is capable of doing work, then the quantity of heat absorbed by the system is equal to the sum of the increase in internal energy of the system and the external work done by the system. Aita? Then what do you mean by thermodynamic process? It is a process in which one or more parameters of thermodynamic system undergo a change. So here the process in which one or more parameters of thermodynamic system. Antandre, what are the thermodynamic parameters? Pressure, volume, temperature, or internal energy, pressure. These all are parameters here. Idralli yavadaದ್ರು ಒಂದು ಕೂಡ change ಆದ್ರೆ ನಾವು ಏನಂತ ಹೇಳ್ಬೋದು? That is, it is called as a thermodynamic process or a thermodynamic change, right? Yes. Then next one. So here we have the isothermal process, isobaric process, isochoric process, adiabatic process, and quasi-static process. So what do you mean by isothermal process? The process in which change in pressure and volume takes place at a constant temperature. So what you need to remember here, that is the temperature is remaining constant, right? So this is called as isothermal change. This is called as isothermal change, right? Then next, it may be noted that in such a change, total amount of heat of the system does not remain constant. So in case of isothermal process, what is remaining constant? Temperature is remaining constant, right? So here when the temperature is remaining constant, the total amount of heat does not remain constant here, right? What is isobaric process? It is a change in volume and temperature at constant pressure. So isothermal process, temperature is constant. Isobaric process, that is pressure is constant. Isochoric process, volume of the system is constant. Then adiabatic process antandre, there is no exchange of the heat with the system and the surrounding. That is adiabatic process. What is quasi-static process? See, the process in which change in any of the parameters takes place at such a slow speed that the values of P, V, and T can be taken to be practically constant. Antandre, so here whatever your thermodynamic parameters are there, it will change. The process is taking place with a very slow speed here, so that the values of P, V, T can be taken, and practically these values are constant. Such a process is called as what? Quasi-static process. So in short, we can say that quasi-static process is one of the slow process here, where we can observe the changes in pressure, volume, and temperature very clear. Next, cyclic process. As the name indicates, cyclic antandre, from where it will start alle bandu end agutte anta, hauda? In a system in which the parameters acquire the original values, the process is called a cyclic process. Next, reversible process. What is reversible process here? A process which can retrace so that the system passes through the same states is called a reversible process. So what is reversible process? So in chemistry, you might have studied about reversible and irreversible process. So which can be retraced, that is called as reversible. Which cannot be retraced, that is called as irreversible process. So irreversibility arises mainly from two causes. That is, many processes like free expansion or an explosive chemical reaction take the system to non-equilibrium states. And next, most processes involve friction, viscosity, and other dissipative factors or the effects. So next one, next here we are going to see some of the equations. That is, consider 1 mole of an ideal gas. Let dQ be the amount of heat given to them. So then according to the first law of thermodynamics, what we can write? That is dQ is equal to du plus dW. dW antandre now nodidvi, that is nothing but change in the volume into pressure. Now, if heat is supplied to the 1 mole at constant volume, so constant volume antandage enagatte. So according to your mathematics, if any value is constant, its differentiation is taken as 0, right? So therefore, dq is equal to du. Then molar specific heat Cv is given by dq by dt at constant V, right? So the equation can be written as for Cv. Similarly, so here dq is equal to du is equal to Cv into dt. We can simplify this equation. All right. Next. So for the pressure, what we can write? Similarly, for the constant pressure, the expression can also be written as Cp is equal to dq divided by dt at constant pressure. Therefore, simplify this equation. dq is equal to Cp into dt. Right? ಇಲ್ಲಿ ನೋಡಿ ಈಗ ನಮ್ಗೆ ಏನ್ ಗೊತ್ತಾಯ್ತು dq is equal to we have here Cp into dt, right? So then, so according to the first equation of thermodynamics, dq is equal to ಏನಂತ ಇದೆ du plus pdv. ಹೌದಾ? du ಅಂತಂದ್ರೆ ನಾವು ಈಗಷ್ಟೇ ಇಲ್ಲಿ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಿದ್ವಿ. You can substitute the value here, that is dq is equal to, we are getting Cp into dt, and it is also is equal to du plus pdv. Therefore, we can say that is du is equal to Cv into dt. Substitute the value of du, that is Cp into dt. So Cv dt as it is. Actually, the derivation part is not required for you. Just I am showing this one. So my conclusion is what from this derivation? There is Cp minus Cv is equal to R anta. Aita. So namge in CET alli derivation en baralla. Namge main formula gottadre sakilli. That is Cp minus Cv is equal to R. What is the meaning of this? That is specific heat capacity at constant pressure and specific heat capacity at constant volume. Its subtraction will give you the value of R. Then the next one is second law of thermodynamics. So what is second law of thermodynamics? Actually, in second law of thermodynamics alli ನಾವು ಎರಡು statement ನೋಡಬಹುದು. One is given by Clausius and the one more is given by Kelvin-Planck statement. So what is Kelvin-Planck statement? It is impossible to construct an engine operating in a cycle to extract heat from hot body and convert it completely into work. So in short, 100% work done ಆಗಲ್ಲ ಅಂತ ಹೇಳ್ತಾರೆ. ನೀವು ಎಷ್ಟು ಎನರ್ಜಿ ಕೊಡ್ತೀರಾ ಯಾವ್ದಾದ್ರು ಒಂದು ಸಿಸ್ಟಮ್ ಅಥವಾ ಬಾಡಿಗೆ, so whatever the work done you are giving, whatever the energy you are giving, 100% work done we are not getting here. For example, suppose if any vehicles are there, car, bike or any vehicles are there, ನೀವಲ್ಲಿ ಏನ್ ಪೆಟ್ರೋಲ್ ಅಥವಾ ಡೀಸೆಲ್ ಅನ್ನ ಯೂಸ್ ಮಾಡ್ತೀರಾ, so the entire, for example, if it is 500 rupees petrol, so entire 500 rupees petrol is not giving you the 100% output of that work done here. How the, so some petrol is getting used to that, the friction is there to overcome that. So whatever the fuel is there or the energy you are giving for other purpose also it will get used here. So 100% work done is not possible whatever amount of energy you are supplying. So this is called as what? Kelvin-Planck statement. The next, Clausius statement. So what is Clausius statement? It is impossible for a self-acting machine operating in a cycle unaided by any external energy to transfer heat from a cold body to a hot body. Antandre, so in short, what is the conclusion of Clausius statement here? Clausius statement prakara, so here the work, that is the process is not possible. Yav tara antandre, cold body in the hot body ge heat transfer agalla anta. Okay, heat always transfers from hot body to a cold body, not from cold body to a hot body. So in other words, heat cannot flow itself from a cold body to a hot body. Idenadru aagbekanತ andre, so automatically it is not possible. So automatically what is possible? Only hot body to cold body ge heat transfer ಆಗಬಹುದು. ಆದ್ರೆ cold body ಇಂದ hot body ಗೆ ಆಗಲ್ಲ. ಅವಾಗ ನಮಗೆ ಏನು ಬೇಕಾಗುತ್ತೆ? Here some external agent we require there, right? So second law of thermodynamics, which was given by Clausius and Kelvin-Planck. Then the next one is to work done in an isothermal process. So as I told you, we don't require the derivation part. So here we have the Carnot engine. So this Carnot engine is named as Carnot, the scientist's name. It is a reversible heat engine operating between the two temperatures. Okay, it has the maximum efficiency which no other engine can have when Then next we have the cyclic process of this Carnot engine. So as I told you, we don't require the explanation. So efficiency is equal to, we will see that it is 1 minus T2 divided by T1. It is T2 divided by T1. Here you can see your Carnot engine cycle. That is PV diagram anta ಹೇಳ್ತಾರೆ ಇದಕ್ಕೆ. So pressure versus volume. Okay, pressure versus volume. That is isothermal process. Andre ನೀವು ಇಲ್ಲಿ first ನೋಡಬಹುದು 1 to 2 it is isothermal process. It is called as isothermal expansion also. Then 2 to 3 it is adiabatic expansion. 3 to 4 it is isothermal compression. Then 4 to 1 it is adiabatic compression. Okay, so now let us go for the question answers based on first law, second law, isothermal process and the adiabatic processes. Yes, so I'll share the next slide. Yes. Okay, I hope you are able to see this one. So here we have the question answers. So maximum we will get some theory questions only in case of a thermodynamics. So here you can see the first question. For an ideal gas in an isothermal process, that is option. So for isothermal process, what happens? Heat content remains constant. Heat content and temperature remains constant. Temperature remains constant, none of the above.
Option C, ma'am.
Next. Yes, it is option C. Option C it is, okay. So in the theory part, we have discussed this one. Yes, everybody is in this answer. Very good. Then the next question is, can two isothermal curves cut each other? Options: never, yes. They will cut when temperature is 0 degrees Celsius. Option D is yes, when the pressure is critical pressure. Yes. It is A only. A, yes. It is A only. That is never. Why? Because you see, isothermal process ಅಂತಂದ್ರೆ ಏನು? Isothermal process ಅಲ್ಲಿ ಏನಾಗುತ್ತೆ? That is the temperature is remaining constant. ಹೌದಾ? So suppose if you say the curves are meeting, suppose if you say the curves are meeting. So ಈಗ ಏನಾದ್ರೂ ನಾವು curve ಒಂದು process ಒಂದು isothermal process temperature T1 ಅಂತ ಇರುತ್ತೆ ಆಯ್ತಾ? So if I take one more process with the temperature T2, so suppose if you say the curves are cutting each other, ಎರಡು ಏನಾದ್ರೂ ಕಟ್ ಆಗ್ತಾ ಇದೆ ಅಂತಂದ್ರೆ ಇಲ್ಲಿ ಏನಿದು ಜಾಯಿನ್ ಆಗ್ತಾ ಇದೆ ಅಲ್ಲ, ಈ ಪಾಯಿಂಟ್ at the point of intersection, what you can say the temperature here? We cannot say which temperature it is, right? So if you are not say we cannot say that the temperature is constant. So for that reason, option A is correct here. That is, they never intersect with each other, like your electric field lines. Let us go for the next question. In an isothermal expansion, internal energy of the gas increases, internal energy of the gas decreases, internal energy remains unchanged, average kinetic energy of gas molecules decreases. So in case of isothermal expansion, isothermal, again heat remains constant, right?
Option C, ma'am.
Yes, very good. So it is option C, that is internal energy remains unchanged as it is isothermal. So many people know this one. Yes, very good. That is option C. Next question. So here solving is there. In an isothermal reversible expansion, the volume of 96 gram of oxygen at 27 degrees Celsius is increased from 70 liter to 140 liter. So this volume kottidare V1, V2. Then here that is temperature is also given. Then work done by the gas will be. So let us solve this. It is given by. So here the work done by the isothermal process, W is equal to, it is nRT log E 2 divided by V1. This is the actual equation for isothermal process work done. Here again, number of moles they have not given, therefore we need to calculate. That is M, capital M, RT log to the base E V2 by V1. So here it is given in terms of log to the base E.
Option B, ma'am.
In terms of option, yes, it is D. So here I'll just show the solution because I'm not going to answer. That is, substitute the value. Yeah, they have given it is 96. That is log to base E ಅಂತ ಇದೆ. Okay. So if you want to convert it in terms of log to the base 10, if you want to convert it in terms of log to the base 10, you need to multiply 2.3. So here I'll multiply it by 2.3. If you multiply by 2.3, then you get it as option D. Option D is correct. So here it is 2.3 into 6 divided by, for oxygen it is 2 into, that is R value. R value I keep it as it is because in the options all the R's are kept as it is only. Then temperature is 27. Here we need to take the temperature by in terms of Kelvin. So Kelvin is okay, students. Now you see what about the voice. Hope so. Now it is clear. Okay, now it is clear.
Yes, ma'am.
Okay, na? Yes. So here we have that is 2.3 into 900 into R log to the base 10 into option D is the correct one here. Option D is correct one. Okay. Yes. Done. Let us go for the next question. A vessel containing 5 liter of gas at 0.8 m pressure is connected to evacuated vessel of volume 3 liters. The resultant pressure inside will be, So here, assuming whole system needs to be isolated. Whole system needs to be isolated means that is, there is no any external factors are affecting that one. So option B, they are saying yes, it is option B. So let us prove this one. Yes, very good. That is, it is based on P1 V1. Yes, option B is correct. That is P1 V1 is equal to P2 V. Then P1 V1 is equal to P2 V2. Therefore, substitute the values here. So P1 is given as, that is 5 liter. It is given as, sorry, V1 is given as 5 liter. P1 is given as 0.8, right? So P2 I'll consider it as P. Then V2 I'll take it as 5 plus 3. Yes, which is equal to 8. So substitute all the values here. So you know P1 value, that is 0.8, V1 value is 5. P2 you take it as P, V2 is 8. So if you go on simplifying, P will be 0.5 m. P will be 0.5 m. Yes. Okay. So the next question. For an isothermal expansion of a perfect gas, the value of delta P by P is equal. So isothermal expansion it is. So in case of isothermal expansion for a perfect gas, the value of delta P by P is equal to their asking. Option A, minus gamma to the power of 1 by 2. Gamma is ratio of Cp by Cv. So what is your answer? Yes. Yes, it is B. Yes, very good. So let us prove this. It is option B. So how to do this one? That is PV is equal to constant. Again, that is PV is equal to constant anta namge gottide illi. So PV is equal to constant anta adaga. I'll take it as P delta V plus I'll differentiate this equation. So after differentiating, what I am getting? P delta V is equal plus V delta P is equal to constant ಅಂತಂದ್ರೆ 0 ಆಗುತ್ತೆ. Differentiation of constant means 0. So therefore, what I can do now, I'll just transfer the terms. P delta V is equal to minus V delta P. Yes. Therefore, delta P by P they are asking. That is nothing but delta P by P is equal to minus delta V by P. Option B is the correct one. Okay, so many students are getting the answer. That is option B is right one. Then the next question, the gas law PV by T is equal to constant is true for. So it is true for which one? That is isothermal change, adiabatic change, both isothermal and adiabatic. Neither isothermal nor adiabatic changes. So PV by T is equal to constant. This is for A, B, C or D. It is C. Yes, very good. It is option C. Okay, then the next question. So see the question. You can try it. You can try and tell me the answer. 1 mole of O2 gas having a volume equal to 22.4 liter at 0 degrees Celsius and 1 atmospheric pressure in compressed isothermally so that its volume reduces to 11.2 liters. The work done in the process is. So what is the answer? Check. It is option D.
Yes, ma'am.
Yes, option D. Everybody is getting the answer. So if somebody is not getting the answer, just hint I'll give you. You can continue with the calculation part. So that is given by, that is work done is equal to. So here work done is equal to, it is nRT, or we can take it as mu RT log to the base E V final upon V initial. That is work done expression. V final upon V initial. So you can substitute all the values here. You can substitute mu is equal to 1. You can substitute R is equal to 8.31. Then T value is 273. Okay. Then next, log to the base, that is VF is 11.2. Then V initial is, that is 22.4. So substitute all the values. Here, whatever the ratio of log Vf by Vi is there, you can take it by applying the log rule, that is log Vf minus log Vi. So based on that, you can get the answer. Yes, okay. So I hope it is clear to everyone. Let us go for the next question. If a gas is heated at constant pressure, its isothermal compressibility. If a gas is heated at constant pressure, its isothermal compressibility remains constant, increase linearly with the temperature, decreases linearly with temperature, decreases inversely with temperature. Now also it is not clear. Okay, what is the answer? It is A or C.
Yeah, ma'am.
It is A. A, na? Yes, it is A. Okay, that is, it remains constant. So if a gas is heated at constant pressure, its isothermal compressibility remains constant. Okay, option A is correct here. Let us go for the next question. Work done per mole in an isothermal change is, work done per mole in an isothermal change is, it RT log to the base 10 V2 by V1, RT log to the base 10 V1 by V2, RT log E log to the base E V2 by V1, or RT log to the base E V1 by V2, which A, B, C, D. Yes.
C, ma'am.
Yes, correct. It is C. Vandana, it is C. Okay, it is very good. This is C answer. That is RT log to the base E, V2 divided by V1. Option C is correct here. Then the next question, the isothermal bulk modulus of an ideal gas at pressure P is. Isothermal bulk modulus. So if you remember, bulk modulus is given by, we can take it as pressure upon change in the volume by initial volume for an ideal gas. Yes. See, the isothermal bulk modulus for ideal gas, it is same, that is P itself. It is P itself. Option A is the correct one here. Option A baratte. Aita. So everyone, option A is correct. Option A. Aita. Next question. In isothermal expansion, the pressure is determined by temperature only, compressibility only, both temperature and compressibility, none of these. The pressure is determined by only temperature. Compressibility will not come.
Option C, ma'am.
Yes. So here, that is in isothermal expansion, the pressure is determined by, here it is determined by compressibility. It is expansion. See, here isothermal expansion we have isothermal compression is there, right? Here they are asking isothermal expansion. So for isothermal expansion, the pressure is determined by compressibility. Expansion, it is determined by compressibility. Option B is correct here. Then the next question, the isothermal bulk modulus of a perfect gas at normal pressure is. The isothermal bulk modulus of a perfect gas at normal pressure is. It is 1.013 into 10 to the power 5. So it is nothing but at STP, the pressure value. So here you do, it is at STP, the pressure value. It is A. Yes, it is A. Next question. In an isothermal state, obeys. Isothermal state obeys. Boyle's law, Sankalp law, Gay-Lussac's law. I don't know what is the problem. Yes. An ideal gas obeys Boyle's law. It obeys Boyle's law. Okay. So if you remember the SPS class we have discussed Boyle's law, Gay-Lussac's law. So Boyle's law, that is temperature means constant. How the isothermal process in the temperature constant, the isothermal change obeys the Boyle's law here. It obeys the Boyle's law. Yes. Then the next. The next question is, in isothermic process, there is nothing but thermal process itself. Which statement is wrong? Temperature is constant, internal energy is constant, no change of energy, no exchange of energy. A and B are correct.
C, ma'am.
Yes. Yes, there is no exchange of energy. Here, which statement is wrong? They are asking. Which is wrong? Okay. Yes. So here it is C. It is C. Next one. An ideal gas A and a real gas B have their volumes increased from V to 2V under isothermal conditions. Okay, so here ideal gas is there and the real gas is there. The volume is increasing from the increase in internal energy is
Option
it will
C,
be
ma'am.
same in okay. It is option C. Yes, that is B will be more than that of A. B will be more than that of A. Okay. Next, the specific heat of gas in an isothermal process is. The specific heat of gas in an isothermal process is. So specific heat is given by S is equal to M.
Option D, ma'am.
Option D remains constant. See here, the specific heat is given by what? That is, it is Q is directly proportional to M. We know that Q is directly proportional to delta T. So we write it as Q is equal to M delta T. Aita, illi proportionality constant now specific heat anta tagotivi. So specific heat S is equal to Q divided by M delta T. So in case of isothermal process, what it is? This is constant. This is constant here. So when it is constant here for isothermal process, this answer is the specific heat capacity is infinity. It is infinity. It is not constant here. Okay. So, but adiabatic process alli enagate? Adiabatic process alli idu 0 agate. ನೀವು ಇಲ್ಲಿ ನೆನ್ಪಿಡಿ, in exam they may ask you about adiabatic process also. So in case of adiabatic process it is 0, and in case of isothermal process it is infinity. I hope the solution is clear to you. As it is isothermal process, our specific heat expression is given by Q by m delta T. ಇದು ಕಾನ್ಸ್ಟಂಟ್ ಅಂತಂದಾಗ ಇದೇನಾಗತ್ತೆ, ಇದನ್ನ ನೀವು ಡಿಫ್ರೆನ್ಶಿಯೇಟ್ ಮಾಡಿದ್ರಿ ಅಂತಂದ್ರೆ ಇಲ್ಲಿ 0 ಬಂತು. ಸೊ ಎನಿಥಿಂಗ್ ಬೈ 0 is nothing but infinity. ಅರ್ಥ ಆಯ್ತಾ? It is option A. Option A. I hope it is clear to you. Let us go for the next question. Okay, option A is correct here. Next question. A thermally insulated container is divided into two parts by a screen. A thermally insulated container is divided into two parts by a screen. In one part, the pressure and temperature are P and T for an ideal gas. In the second part, it is vacuum. So one part only pressure and the temperature, it is constant, and the other part it is vacuum. If now a small hole is created in the screen, then the temperature of the gas will be. Yes.
Option C, ma'am, remains same.
Yes, it is C. Option C, it remains the same. Option C is correct. Option C is correct. Next question. A container that suits the occurrence of an isothermal process should be made of copper, glass, wood, or cloth. Yes, it is copper. So here the answer is it is copper. A container that suits for the occurrence of an isothermal process, it should be made up of what? Copper here. Okay, so many students know the answer here. Then the next question is, in an isothermal process, the volume of an ideal gas is halved. One can say that. So ಇಲ್ಲಿ ವಾಲ್ಯೂಮ್ ರೆಡ್ಯೂಸ್ ಮಾಡ್ತಾ ಇದ್ದೀರಾ ಅಂದ್ರೆ ನೀವು ವಾಲ್ಯೂಮ್ ಅನ್ನು ಏನ್ ಮಾಡ್ತಾ ಇದ್ದೀರಾ, ಹಾಫ್ ವ್ಯಾಲ್ಯೂಗಾಗಿ ರೆಡ್ಯೂಸ್ ಮಾಡ್ತಾ ಇದ್ದೀರಾ. So what happens here? Internal energy of the system decreases. Work done by the gas is positive. Work done by the gas is negative. Internal energy of the system increases. Yes. So isothermal process, the volume of an ideal gas is half. One can say that. So in the beginning, first two slides we discussed, see, work done and internal energy, when it is positive, negative. So here in case of isothermal process, when the volume is reduced here, the work done, it is C. Yes, that is the work done by the gas is negative. Work done by the gas is, yes, very good. So the work done by the gas is negative. Option C. Yes, let us go for the next question. That is for adiabatic process. Okay, if a cylinder containing a gas at high pressure explodes, the gas undergoes. So here a cylinder explodes due to the high pressure. So the gas undergoes reversible adiabatic change. A, that is reversible adiabatic change and fall of temperature. Reversible adiabatic change and rise of temperature, irreversible adiabatic change and fall of temperature, irreversible adiabatic change and rise of temperature. It is A or C. It is a reversible process or irreversible process. You reversible anta helidre, whatever the explosion is taking place, you are able to regain that. Howda? If you say it as a reversible process. So ಒಂದ್ಸಲಿ ಅದು ಏನದು ಎಕ್ಸ್ಪ್ಲೋರ್ ಆದ್ರೆ ನೀವು ಅದನ್ನ ಮತ್ತೆ ಸ್ಟೋರ್ ಮಾಡಬಹುದು ಅದೆಲ್ಲ ಎನರ್ಜಿಯನ್ನ. Is it possible? then it is reversible. If not, then it is irreversible. Option A or it is option C. See here, that is the cylinder containing a gas at high pressure. If it is exploding, you are not able to retrace the equation or retrace the reaction here. Therefore, here it is an irreversible adiabatic change and fall of temperature. That is option C. Option C is correct one here. Option C is correct one. Next question. The work done in an adiabatic change in a gas depends only on adiabatic change. It depends only on change in pressure, change in volume, change in temperature, none of the above. Yes. That is option C. It is option, yes, it is option C. Change in the temperature. Okay. In adiabatic expansion, so in the adiabatic expansion, the change in internal energy is 0, the change in internal energy is negative, it is positive, or it is 0, or work done is 0.
Option A, ma'am.
Option A. Or work done is 0 or internal energy is 0. See, here they asked in the previous question about the specific heat. So, ನಾನು ಇಲ್ಲಿ ಏನು ಹೇಳಿದೆ ನಿಮಗೆ specific heat ಏನಾಗುತ್ತೆ for isothermal process it is infinity and for adiabatic process it is 0. ಇಲ್ಲಿ ಏನಿದೆ question ನೋಡಿ, ಇಲ್ಲಿ ಅವರು specific heat ಕೇಳ್ತಾ ಇಲ್ಲ. Here they are asking you the adiabatic expansion. Here the work done is 0. It is the work done is 0, students. It is option D. Confused ಮಾಡ್ಕೋಬೇಡಿ. It is option D. ಅಲ್ಲಿ ಸ್ಪೆಸಿಫಿಕ್ ಹೀಟ್ ಅಂತ ಇತ್ತು ಆಯ್ತಾ, ಅಲ್ಲಿ ಸ್ಪೆಸಿಫಿಕ್ ಹೀಟ್ ಅಂತ ಇತ್ತು. ಅಡಿಯಾಬೆಟಿಕ್ ಎಕ್ಸ್ಪಾನ್ಷನ್ ದ ವರ್ಕ್ ಡನ್ ಇಸ್ 0. ಎಸ್, ಓಕೆ. ನೆಕ್ಸ್ಟ್ ಕ್ವಶನ್. The pressure in the tire of a car is 4 times the atmospheric pressure at 300 Kelvin. At 300 Kelvin. If this tire suddenly bursts, its new temperature will be. So gamma value kottidare avaru. So for adiabatic process, take the help of the adiabatic work done. Then you can simplify this one. So here the solution is what they are saying. You the pressure is 4 times of the atmospheric pressure. How the temperature estanta heltidare? It is 300 Kelvin. Gamma value is 1.4. So, according to adiabatic process, it is given by T raised to gamma in terms of Tp. I am taking P raised to gamma minus 1 is equal to constant. It is equal to constant. Then next, T2 divided by T1 is equal to P1 upon P2 to the power of 1 minus gamma upon gamma. Next, here it is T2 divided by T2 only we require. T2 is equal to T1 is 300, which is equal to 4 upon 1 to the power of 1 minus 1.4 upon 1.4. So if I simplify this for T2 is equal to, it is 32 is equal to 300 into 4. It is 300 into 4. To the power of minus 0.4 upon 1.4. Yes. So it is which option?
Option D, ma'am. Option D, ma'am.
Okay, okay. Yes, it is option D. It is option D. So here, diabetic process. Yes, this is option D. It is correct. Option D only it is. Option D it is. Okay. Then the last question of today's class. Here they are saying, I hope this question is clear to you. In the tire is 4 times the atmospheric pressure, and the pressure P is equal to 4 times of atmospheric pressure. Temperature ಎಷ್ಟಂತ ಹೇಳಿದ್ರೆ, if the tire bursts completely, then it's two we need to calculate. So it is a diabetic process, so therefore we are taking it TP. Yeah, I will TP. In terms of T also we have the equation, ಆಯ್ತಾ? But we are not considering that because volume ಬಗ್ಗೆ ಅವರೇನು describe ಮಾಡಿಲ್ಲ, ಅದಕ್ಕೆ ನಾವು TP, in terms of TP we are taking the formula. Last question. A gas at NTP is suddenly compressed to 1/4 of its original volume. If gamma is supposed to be, that is 3/2, then the final pressure is. So here how we can do this one, that is given by V2 is equal to 1/4 of V1, gamma is equal to P by 2, gamma is equal to constant, that is P2 divided by P1 equal to V1 by V2 raised to gamma, which is equal to V1 by V2 to the power 3 by 2. Yes. So what is the answer? A, B, C, D.
Option D, ma'am.
D you are getting, or C you are getting? Okay, student, as you are saying that the voice is not clear in the class, so I'll check what is wrong today. If it is not clear, tomorrow we will repeat this. So ನಾಳೆ ಇದನ್ನ ಬೇಕಾದ್ರೆ repeat ಮಾಡೋಣ. I'll check the recording once again. If there is any problem, we will repeat the class for the question or how it will go. We will see. Is it okay?
Okay, ma'am.
Check that. Okay. You people are saying that it is breaking. I'll see that one. And yesterday is that one question C, that is option B only it is correct. That is √2:1. Question number 17. New kadege nodi. Question number 17, option B only it is correct. Yes. So I'll check out that. If any problem is there, I'll correct it. ನಾಳೆ ನೋಡೋಣ, ನಾನು ಚೆಕ್ ಮಾಡ್ತೀನಿ ರೆಕಾರ್ಡಿಂಗ್ ಅನ್ನ ಮತ್ತೊಂದ್ಸಲಿ ಚೆಕ್ ಮಾಡ್ತೀನಿ. Okay. Thank you everyone. Have a good day.
ಫ್ರೆಂಡ್ಸ್ ಫ್ರೆಂಡ್ಸ್ ಮಾತಾಡಿ ಯಾರಾದ್ರು